We were in 37 regions now, and you could almost say it's like 37 slightly different problems. I think so much of startups is like rolling the dice on things. We ended up shipping this sort of YOLO mode because we had to get it out because things were crumbling. Other than it being like a complete cluster and a hair on fire and a full-time cortisol injections, it was actually pretty cool to see how fast new people were able to really meaningfully do stuff.
Hi, I'm Brett Gibson, and welcome to HiBit, a new podcast where we do deep dives on the art of problem solving with engineers and technical experts from our community of early stage startups. In today's episode, we're sitting down with Kurt Mackey, CEO and co-founder of Fly.io, a developer-focused public cloud. Before this, Kurt was the founder and CEO of Compose, a company that builds database operations software. The details of engineering problems fascinate me, but I'm just as interested in how the best engineers I know think, how they zoom in on which details matter the most, and then use that focus to navigate to elegant solutions. Join me on this journey as we discuss thorny engineering problems with my guests and get into the weeds about how they solve them. Hey Kurt, thanks a lot for joining me today.
Yeah, thanks for having me. I'm excited about this. I'm like fun FaceTime.
Maybe we can start off by you describing what Fly.io is and what you do.
Sure. Fly is a developer-focused public cloud, effectively. It's basically if you fast forwarded 15 years from 2008 and started AWS again, but entirely focused on developers. We kind of pride ourselves on being just a platform for getting compute where you need it, which tends to be close to users. And for the big future of public cloud, we're one of like 50 companies we lovingly call the Rebel Alliance that are going to kind of team together to give devs much better individual products than they're currently getting from the big guys with their 400 product portfolios that have maybe 4 good ones and 300 mediocre ones and 90 that nobody knows about.
Awesome. Yeah, maybe you can contextualize that a little bit more. What was the trend that went into setting up the original big public clouds that needs to be fixed, other than, certainly other than a focus on, developer excitement and joy?
I think those are linked, but the big thing that happened is all the public clouds grew out of physical data centers and emulated physical data centers. And they did amazing things by giving you like API control over things that you would have had to use physical hands to do before, like getting new disks and getting servers online and all of this stuff. But they're still tethered to the original data center concept, which means that you ended up with like a lot of infrastructure running in Virginia for people that live in Tokyo or Sydney. And if you started from first principles, and especially at this time in life after we've had, COVID, we're all on video synchronous calls all the time, using async stuff, working remotely. It wouldn't have made much sense to do it that way. Even our company has 75 people scattered all over the world. Virginia is not really the best place to put things that they need to use. The best place to put things is close to them for the most part. And so one big thing you would do if you started now is just forget the whole notion of a physical tether where your stuff has to be. There's some legal requirements that you might want to adapt to, but I think the idea is to have a cloud that's flexible enough to run your app where it needs to be, which often means in multiple cities. I think the developer experience is probably interlinked because what happened with AWS is they built this stuff not necessarily for developers. They were sort of selling this to people. I mean, S3 was actually very pure developer, but their later products were more focused on kind of like platform engineers, people who run the internal platforms for teams. And it's like a layer developers have to go through to get things shipped. And so this is absolutely why you'd end up with a data center that's in a physical or a region that's in the same location as the data center was, because this is what the platform teams have used to running before. But they didn't really like step back and look at what developers shipping apps actually needed to be able to do and start really using the infrastructure to solve the developer problems. So it's I think it's both a time and an evolutionary thing and a who the customer is that kind of makes what we're doing different and I think necessary.
Yeah, that's really interesting. It makes a lot of sense how if you're used to taking a server down to a physical colo, then the natural next step is to do a cloud-based service where you pick a location. Like why wouldn't that be part of it? If you step back, we just saw the outcropping of like what that meant and the things people had to do to sort of hack around it.
Right, exactly. And it's actually kind of fun to give devs the local experience. One of the things that we built into the platform is when you launch an app for the first time, we just default to putting it in the city you're in. And so we've had a bunch of people like ship boring Rails apps in like Tokyo and be astonished with how fast this thing was because they've never actually experienced infrastructure close to them before. It was kind of funny. It's a little bit of an endorphin rush every time that one happens.
Oh, that's really cool. I hadn't heard that before. That's a really awesome hack. But it makes perfect sense when you describe it. Okay, my next question is, what's particularly hard about this? I imagine a lot of things in terms of it's like degrees of bare metalness, right?
Yes.
Layering on abstractions.
What's hard for us is we did go from the bare metal up and then ended up having to solve the entire bit of software on bare metal through the user problem ourselves. And so there's a logistics nightmare in here because we were running servers all over the world and having to figure out how to get them through certain people's customs, do capacity planning, deal with, things like natural disasters that crop up when you're doing this or supply chain issues. And then there's a really difficult technical software problem that we've kind of unearthed over time, which is that infrastructure software that exists for running your own stuff isn't really built for what we're building. And so early on, when we were not sure if we were going to have a successful product or not, we made some choices about open source tools to use in the interest of getting something out and having people use it. And then over the subsequent 3.5 years now, we've basically had to replace all those with our own code, which means inheriting or creating giant global distributed systems problems that are the stuff of scientific papers sometimes or theory more than they are actually running in the wild.
Yeah, I mean, that all makes a lot of sense. Digging into both of those, was there a particular moment when you knew these problems were specifically acute? Or has it been kind of linear in terms of addressing these?
It's been a ride. The hardware one's interesting because we've raised $100-ish million and still don't have enough money to do big data center installs the way the big clouds do. It's an endlessly expensive problem to solve with money. There's no way to solve what we're doing with money ahead of time and actually build any kind of viable business. So that one actually cropped up about a year ago. We had really good growth, and then about just a little over a year ago, we basically just exploded. And we had probably enough hardware for 3 months of growth at the rate we were going, and we exhausted it in 4 days. And that one got interesting because we didn't really have a bunch of tooling for managing constrained capacity. We created a lot of reliability problems for users because we just couldn't keep up with the demand. That one hurt, and I think that was a thing that is just part of doing a startup. What was the word someone used? Is catastrophically successful is basically what happened. Yeah. I think we kind of thought that would be a problem. We thought we'd have to do capacity management at some point, but it turned so fast, I think we were all super surprised about it. The software stack is a slightly different issue. Performance and scale are orthogonal. And so in general, hardware is the scale problem, software is the performance problem. We kind of knew there were performance constraints for the stack of open source software we're using. We're largely using HashiCorp stack, which is primarily Nomad and Consul for our purposes. And so Nomad does orchestration. Consul's service discovery, which is the global kind of registry of where things are running that allow us to route traffic to them. Once we knew the product was popular, we kind of started looking at replacing the bits of the stack that weren't performing the way we wanted. One of the really interesting problems we had is if you launched an app in Sydney, a VM would come up in Sydney, we'd have to write all this data back to the US and then wait for that data to sync back to Sydney before we could route traffic to it, before users could see the effect of this, which was very slow from a user's perspective. It would take 20 or 30 seconds to get a VM up and running. And a lot of the workloads we wanted to address and a lot of dynamic scaling we wanted to do needed more 500 milliseconds. And so 2 years ago at this point, we started replacing Nomad and then Consul because we knew that it just wasn't going to sustainably let us build kind of the experience we wanted. But then the inflection point hit those too. We suddenly had capacity issues with software that we weren't ready to ship yet because distributed systems are really, really scary and hard and untrustworthy, and nobody believes that they're doing what they're supposed to be because it's actually hard to confirm this sometimes. And at that point, we ended up shipping them under duress, which is maybe the only way we were ever going to get them shipped. We kind of had to start putting out fires, rolling out new pieces of software because it ended up solving scaling problems for us at the same time we were doing all this server stuff. And so I think we just got a little dose of everything. I've told people we're about 3 months out of sync. We probably needed 3 more months of work on the software to be ready to go, which in hindsight feels really lucky for a startup like ours. I can't imagine anyone ever just nailing the timing on this particular thing, but only 3 months in the grand scheme of things feels pretty good now. It did not in February, but it does now.
How much of the team was working on that? Did you have to move resources around?
Oh, so that was the other fun thing that happened is a year ago, we were running basically a public cloud with 25 people. So there weren't really really much of a team. It was a lot of people doing double duty. We're now at 75 and and it's almost all technical product and infrastructure people now. We don't really have any go-to-market hires yet. This is like the right size for what we've been trying to do right now, which feels pretty good. We probably had about, I don't know, a third of the company working on replacing these pieces of the stack before traffic just blew up. And then two things happened when we exploded in popularity. We hired people to build out our infrastructure faster. People that have like done this before at places like GitHub have seen all of this because they came in with like default the right way of solving this that we didn't have to reinvent the wheel on. And then we actually got most of the company working on, broadly we were calling it reliability issues, but it was a lot of getting this new infrastructure out. So one of the big things we had to do to replace both Nomad and Console was like redo our tooling and the whole deploy pipeline and the way people doing a Rails app, for example, deploy and make it compatible with this new stuff, which was a lot of very grindy work that we were able to get a lot of people involved with, a lot of new hires involved with. Other than it being like a complete cluster and a hair on fire and everyone like just full-time cortisol injections, it's actually pretty cool to see how fast like new people were able to really meaningfully do stuff on these things. It was, again, we've got scars, but it's kind of a fun bonding moment in some ways.
At the point the inflection hit, did you have line of sight on, this is like a pretty hard, like big distributed systems problem, like were you like, we know how to fix this, it's some quantum of engineering, or was it like, we still have to figure this out?
It was, we still have to figure this out. I think console in particular is a really interesting problem for us because I mentioned the Sydney to US to Sydney slowness. And one of the things about service discovery is there's not really a reason to have a centralized database with all the services. What we did is we have an open source project called Corrosion we've shipped that we use to replace this. And this is kind of a peer-to-peer gossip-based CRDT engine that lets us like write a service in Sydney. It propagates fast, so everything else in Sydney sees that service before everything does in like Virginia or Sao Paulo or something. It's an interesting distributed system problem because literally no two nodes in our fleet have the same data at any given time. It's so based on what you're close to and how fast kind of the ripple propagation went out across the world. And these things are happening from every angle. They're from every city at all times. So like Frankfurt sees something very different than Sydney, which sees something very different than Hong Kong, which sees something very different than Toronto. I don't think we had line of sight on how to actually manage this. I think that particular problem is very hard to solve, where you can't really trust the data. You just have to be pretty sure it's good and look for things like user-facing errors where it's out of sync. We ended up shipping this sort of YOLO mode because we had to get it out because things were crumbling. And in some ways, it actually accelerated. I think it made us faster to figure this stuff out because we got to see it in real life instead of just theorizing about it and trying to imagine the ways in which it would go wrong, which the ways it broke were not different or were not the same as we would have predicted anyway. Maybe it was a necessary step. But I don't know that we've ever had line of sight on this is the right time to swap out all this infrastructure. It's very much building the airplane after you've jumped out of the airplane after the building. What that's terrible. I just wrecked that one.
It's an emergent system.
It is.
Do you think you could have been ready?
I think we could have. I actually think we were pacing it pretty well for the growth we had. And I think what would have happened is we wouldn't have been like ready in the sense that we were ready to flip a big switch. We would have been able to more incrementally roll out these changes. We ended up kind of really pushing those fast because we had to. But I think if we'd had 6 months to incrementally get this stuff out, it would have been fine. Although I'll always take the growth. This is why we do the startup thing, and it's the good, bad problem to have. I think we would have made the transition pretty smoothly, but never really been ready to throw a big switch. What compressed was how fast we had to make the transition, mostly.
Was there a moment when you're like, okay, great, this works, like we did it, or is it still a day-to-day thing?
No, there's been a few of those. Like the capacity and logistics of getting servers around is a grind. There's never like an epiphany where you're like, we've crossed this chasm now and there's no looking back. The corrosion work, there were a couple moments I remember. One was when I saw how fast it worked once. It was like one of those things where you don't need scale to see. You can just witness from a user's perspective that something just went way better than it was going before. What we were doing is propagating health checks so fast that our load balancer was routing more successfully around broken instances than it had before. And seeing that was like, woohoo, like a little bit of Christmas fun that particular day. We had a similar thing with Nomad where we saw how fast we could boot a VM in any part of the world. And that was super exciting. And then that one's fun because we have customers now come be like, well, I've got Postgres, like Supabase can boot up a Postgres in 250 milliseconds on the platform, which is pretty incredible. So like software-wise, I think we did cross the chasm. And we had like one incident with corrosion where one thing about a distributed peer-to-peer gossip system is it distributes bad data really fast also. It's not just the good data. It's like if any crap gets in there, it also goes around the world really fast. And so it was like, oh, wow, this worked too well for that particular bug we introduced into the system. But otherwise, it hasn't been much of a grind. It's been more of a like step function work for those.
Did having to build that also present like a bespoke monitoring and like telemetrics problem that you had to build alongside it to even understand if it was working?
Yes, in some ways. Actually, the monitoring stack has a similar issue as the other things where it's largely centralized in the US, and it's not ever going to be a hair on fire to replace that. It just doesn't work as well as we want it to because we haven't gone back and made this work for like a global cloud platform yet. There were a couple of things with corrosion where I'm trying to remember what we were comparing. There were times when we were like literally like comparing data across 2 live servers to see if there's any disparities, and not like granular disparity. Like we're looking for statistical correctness here because it's never exact. And so we had to do a lot of that work. We had to get good at seeding new hosts with this stuff. I think at one point it was like 30 gigs of data running around, and you don't want to wait for the gossip and CRDT to ship all those changes. So there was a lot of streaming. We basically built a database in some ways with bespoke operational and metrics just baked in as we needed them.
Yeah, that's wild. Okay, I guess switching back to the infrastructure side, could you talk a little bit more about what does it actually take to stand up hardware all around the globe? What is it, is it, imagine people's mental model, they're not really sure. Is like, if it's like a bunch of people in each country with a data center.
Yeah, it's a lot. And it's we were in 37 regions now, and you could almost say it's like 37 slightly different problems depending on which region. So what we do is we have a relationship with a company that runs a lot of their own data centers, and we use them for the bulk of the footprint. But in far-flung regions like Santiago or Johannesburg, which I guess is far-flung for us, but not the people who live there, we end up working with specific data center providers that have humans available to touch the hardware, put it in and plug it in and change network cables. We found more bad network cables than I knew you could have. That was a problem I didn't anticipate. It's almost like getting a laptop and turning it on, but we're shipping servers to a place and having someone else turn it on after it's successfully made its way through customs. One of the more interesting problems that I've now learned about is that customs in various countries likes to hold up shipments for any kind of reason, to the extent where some of them are arguably looking for bribes. There's like corruption reasons to do this. And so in some countries, we've now learned that we ship servers individually and not in a big clump because some of them are going to get held up. But it's better than if all of them happen to get held up once. For example, we've learned to use actually shipping services. Like you don't use FedEx to South Africa or things just don't ever arrive. You have to actually use very specific shipping services, very, very specific countries, which is bananas to me. We ran into supply chain issues because we couldn't get power supplies for a bit. Disks were hard for a while. Now it's GPUs that are the problem. So like that's been fun, is like we're kind of at the mercy of the world and a relatively small buyer of this stuff.
But it almost sounds like, because you're never really sure, you have to be ready for any environment you send these things to. It's almost like a packaged good where you have to be sure that it works out of the box no matter who is pulling it out of the box.
It's actually true. And one of the things for our first batch of GPU servers, we put them in 6 regions, found out they all needed big fixes and had to ship them all back to Chicago, mess with them again and ship them back to the 6 regions again. And so for the most part, we got pretty good at it. When we do new kinds of hardware, it gets weird, but that is a whole little adventure. The nice thing is it's pretty commodity stuff. Yeah. Like it's not hard to find people who can mess with this. We get like remote access to the BIOS and things if we need it. We can like have them put a live CD in and boot Linux and do stuff like we would if we were touching it ourselves. It's just kind of very high latency to get that work done.
Yeah, that makes sense. There's a constrained number of things that you can plug into the back of a server, but someone should still do like a fly unboxing, like YouTube video.
You know what? I don't think I've ever seen any of our servers in person. So yeah, maybe it should be me. I should go somewhere and go to South Africa and unbox
I got my new fly server. I'm going to put it in the rack.
Oh, the other really surprising thing ran into was power capacity issues. It's like there have been regions we couldn't add more servers to because the data center had no more power for us and had to actually go work with the grid providers to expand capacity so we could put in 3 more servers. It wasn't like we were doing a whole floor at that point, which was bananas and interesting.
Yeah.
And power expense has gotten fun because wars make power expensive, and there's been a lot of that in the last few years. And so a lot of power. Yes. Yeah. We're arguably just a power municipality at this point. It's kind of what every computer reduces to, is like just the power underneath.
So what were your learnings about it? Or what did you have to put in place to get this global distribution and infrastructure set up? Did you have to meaningfully change the organization, or like how are you approaching this?
I mentioned we were 75 people now kind of comfortably running what we're doing. We had to build, it's expensive. It's really expensive. And probably half of the 75 people are in some ways like kind of there because we have to manage our own physical hardware. We couldn't actually build what we're doing on top of an existing public cloud. But if we weren't having to manage the hardware and there was a theoretical cloud like us that existed, we could do this with far fewer people. Effectively. We hired people who knew this stuff really, really well, but there's still been some like kind of institutional learning that's happened. And there's just a lot of wiki documents and spreadsheets floating around, just like everything else that happens, that we've had to kind of develop over time, which is fun. The thing we haven't done yet that I'm very much looking forward to is getting our own custom chipsets. So like this is what AWS did with Graviton. And someday we'll be big enough that we're building our own silicon or outsourcing it to some company in Taiwan to get the performance we need, or it's usually the power, to kind of get power usage to where we need it based on what the actual users' apps are doing. I'm very excited about this one. I'll get to watch it happen, but it'll be fun to hire people that know how to do this thing.
Yeah, that's the next constraint, like power usage in these locations you don't control because I mean, is there a step where you actually have to go stand up data centers?
I think so. One of the things about the way our infrastructure works is we actually have smaller footprints in each region than you'd expect, because it's almost like we have 1/37th of a data center in each city, because our workloads are actually very distributed, which makes this a little easier. But I do think there's a point where, particularly as we do more GPUs, as we buy more power, it'll make sense to go direct to real estate companies that specialize in data centers, like Digital Realty Trust is one. That's probably the next thing for us, is going and working with one of those companies, getting a floor in one of their existing buildings, and then starting to do things like put a data center in Iceland where power is cheap and it's cool or something. That'll be fun and exciting when we get there.
So overall, do you have high level learnings about how you like attack these problems? I mean, there's some measure of reaction to everything coming at you. What is your takeaway on how to if you were to give someone recommendations on the mindset they need to scale up such a service?
One of the things we really benefited from was having a lot of old school internet people who understood data centers and servers working here. The kind of institutional knowledge that they brought in made a lot of this a lot easier than it would have been if we'd never like built and racked our own servers before. And we saw this when we hired to build out the footprint and to get us at a capacity. There's no substitute for experience seeing all these things. And it's hard to find these people sometimes, but I'm grateful that we managed to. I think the other one is the more low level you go with this stuff, the farther ahead you have to be able to guess what could blow up on you. I think that particularly with the software, we have a pretty good idea of what we want to enable for users over the next even 3 years at this point. And we have a pretty good idea of where what we have is just not going to work for that. And as we get bigger, it's going to be more like 2 years of work to get this stuff in place. I think we're lucky we started on the software transition almost earlier than was comfortable. I think so much of startups is like rolling the dice on things. And that's a dice roll that I was a little hesitant on, because you don't want to like rewrite everything. We sort of started asking this question of, if this company is successful, what's going to kill us, basically. And the corollary to that was like, well, if the company is not successful, the work didn't matter. Like nothing actually mattered. So it's not really wasted work to start working on this stuff. And this company is going to explode in a good way and start getting ahead of that. That's actually been the most counterintuitive thing for me, like at every stage of the startup, was making the right assumption about success and making the right choices based on the success we want to have happen, without getting way too premature about optimizing things or committing to stuff that's wrong, if that makes sense.
Yeah, it's an interesting balance, because you have to play toward the bigger opportunity, but you have users kind of tomorrow that you need to start with a feature set for.
And you have burn, and you've got to move fast, and it's like a whole fun thing.
Having experts in what had previously done, it sounds like what's interesting there is I don't know, maybe you can tell me if this is wrong, but it's not just that you found people who knew what was going to break when they sent a server to a given thing, but having those people on staff informed how you built software.
Yep. Yes, it did for sure. And even actually some of the user work we did early, our very first customer actually, we had tiny servers in Tokyo, and they ran a workload that somehow shifted all their traffic to Tokyo and just melted those things down effectively. Not physically. I think they were probably fine, but we just couldn't handle it. And so we gained some of that experience on the job here, but I think a lot of how you architect this stuff comes from just understanding deeply how the internet works and how things can go wrong. And so like now the platform's actually really good at like basically we can spill traffic over between regions if one gets really overloaded, which is one of the best features of the platform for people running apps is you can actually run one VM per region. And for the most part, users won't ever notice if one region happens to get overloaded because it just falls over to the next one that's like 50 milliseconds more like farther away. So that was super cool. But I think part of our hiring process now, we look for people who can deeply understand the user problem and the technical problem. And both of those things are so important because so much of what we want to deliver for users to solve their problems has big technical implications that inform how we want to architect this stuff. And so much of that has to do with like what's actually possible, like what's possible when you're constrained by the speed of light, which is my favorite thing to tell my parents, is that like we wouldn't exist except the speed of light's too slow. My dad repeats that to everyone. He thinks it's fun.
Yeah, that's awesome. That all really resonates and is fascinating. I guess, what do you think we should be looking forward to out of this new developer-facing stack trend that you're part of?
I think the most exciting stuff that's happening outside of the big public clouds are kind of every bit of infrastructure is becoming something a developer can get more power out of. And for the most part, there's not as many compromises there used to be. So like Supabase is a great example of this, where Firebase came around. It was easy to ship day zero applications. But it was sort of hard to be successful on Firebase over time because you just run into its limits. And so you're seeing companies like Supabase do a Firebase sort of take, but also let you kind of punt to lower levels and just use Postgres. So Supabase turns out to be just building like a really good Postgres service with a lot of infrastructure to make developers move faster on top of it. PlanetScale is the same for MySQL, where they're using Vitess, which is an absolutely phenomenal piece of software. And they're letting people do things like branch deploys of schema changes. They're actually like making the deploy process faster. They're doing partial caching of queries in different places. And so it's letting people build better applications. And then for our part, like one of the interesting use cases we've discovered is we built this API for just turning on isolated VMs very quickly. And we found a huge number of apps that benefit from being able to run untrusted user code. And so what we ended up doing was building infrastructure to meet human performance, like human instant latency performance needs. And then came across this use case we were kind of surprised by. It was like an emergent use case. We have people doing things like generate code from ChatGPT, run it in one of these sandbox VMs, get the errors back, hand it back to ChatGPT, run it in a sandbox VM again. And it only works because we can boot up these isolated VMs so quickly that they can actually just call an API to make this stuff happen, which is very cool and amazing. So like I tend to look at this as like infrastructure should help developers ship new kinds of apps, not just be kind of the target for yesterday's apps necessarily.
So it sounds like a big part of what was going on is that you actually had to be growing fast to even realize how to solve these problems. Is that true?
Yeah, I think so. I think so much of a startup is being pragmatic. We had to be growing fast to make it worth solving some of these problems. We had to be growing fast to make it worth rewriting this whole stack of orchestration and service discovery, because we could have just done that in a vacuum with no users and it would have made no impact on the world whatsoever. In some ways, we are fortunate we started growing so fast that it became, we absolutely have to invest in this stuff at a rate that we couldn't justify otherwise. For capacity too, I think the thing about doing physical hardware is you can spend all the money you have on this stuff if you're not careful. And so growing fast makes it easier to gamble at the right times on those things. So yes, I mean, nobody here is going to disagree that like startups have to grow fast or they die.
Yeah. But
and those are two ways we've experienced that.
Yeah. But it's also like some of the inputs to the problems were learnings from the growth.
Yes, I think that's true. I think if you went deep on our infrastructure, most of us could actually point to what big thing happened from growth, basically, that made us have to make that particular choice. When we started growing so fast that we ran out of servers, there's just things we learned about how to operate these things that we couldn't have possibly figured out otherwise, which is, it's a fun feedback loop in hindsight. Day of, it's like, wow, this is what are we getting ourselves into? But in hindsight, it's like, this is a great little loop.
Well, this has been really fascinating. I really appreciate the time. Always really awesome to talk about everything, all the fascinating problems going on at Fly. So thanks a lot for talking to me today.
Anytime. This stuff, in some ways, talking about it just reminds me of things that I haven't thought about in a while. So it's always worth it.
That's it for this episode with Kurt Mackey, CEO and co-founder of Fly.io. And this wraps up season 2 of our show. HiBit is produced by Initialized Capital. Our showrunner is Candy Chang. Our videographer and editor is Kevin Heinz. And I'm Brett Gibson. Thanks for listening.